Hello everyone, this is Prem Subash. I'm a senior solution architect with Snowflake. This video is on Python Profiler for Snowpark Python store procedures. In this video, we will look into how to enable the Python Profiler and the Profiler options, and how to view the Profiler output, and how to interpret the Profiler output to optimize the store procedures. Let's get started. So it is a tool to analyze your store procedures. It helps you to understand how much time or memory each line of your code consumes. This is mainly used in troubleshooting to optimize the store procedure. Assume you have thousands of lines of code in your procedure and you want to understand which part of your code is not performing well. All you have to do is leveraging this tool to capture stats of each line of your code in a report. You can configure the profiler to generate a report for time-based or memory-based for each line of your code. So here is how you profile your Python store procedures. There are a few setup steps to set up your session parameters. To start with, you have to set up the Python profiler target stage equal to your Snowflake stage location. Here is where the reports will go in after you run the profiler. And then you set up your active Python profiler either equal to a line or equal to memory. And then you invoke your Python store procedure. After the store procedure is completed, you'll be able to pull the report either from a stage location, or you can run this system function by passing in the query ID to get the report in your snow side. There are a few considerations, and this profiling is meant for lower environments like either in a dev or QA, and definitely not recommended for production. Regarding permissions, you need to have a read-write privilege on the Snowflake stage, and also you need to have a ownership on the store procedure. On the limitations, currently it supports only store procedures and not UDF, and also you cannot have a recursive profiling like calling a store procedure with a store procedure. Regarding module inclusion, let's say you have a store procedure referencing multiple Python modules from a Snowflake stage. You need to set up this parameter before invoking a profiler. With that, let's quickly jump onto our demo. For the demo, I have a simple Python store procedure here. All it does is like read a table from the TPCH dataset, customer table, and it does a filter for market segment equal to automobile. And I'm trying to get the average balance of this column, account balance. Firstly, I'm leveraging pandas to show the time it taking to do a conversion from Snowpark data frame to a pandas. I know this is not the optimal way, but I just want to show how much time it's taking to do that to pandas in terms of time wise and for memory. And maybe in the later part of the demo, we can show optimally how we can do via Snowpark data frame the same operation. So let's create this store procedure, and let's try to set up all these session parameters. So I'm firstly setting up this use cache result equal to false to make sure I'm not getting anything from the cache. And I'm setting up the Python profiler target stage to the stage location. And to start with, we'll set up the active Python profiler equal line. And here is a count of the table and the filter automobile. There are 15 million rows in the table, and there are 3 million rows for the market segment equal to automobile. And let's invoke this procedure. So now it's going to collect the stats for each line of the code, how much time it's going to take, and it's going to pull up the report. So either you can get the report from the stage location, or you can call in this system function by passing the query ID. So here is a output. Let's invoke the system function with the last query ID, and here is a report. And let's copy this, and probably for readability sake, like let me go to my VS Code and paste this output. A few things you can see, something like the total time it taken and the modules, and also you can see the line numbers, and there are also hits and the time it consumed for each of the line of code. This is in milliseconds, and per hit what the time taken and the percentage of time, and you can clearly see this 97% of the time is taken to convert the data frame from Snowpark to Pandas, and the time taken is close to this 15,000 milliseconds, which is not optimal, by the way. Now let's go back to the Snowflake account and try to run this for memory. Okay, this is setup is done, and then I'm going to invoke the same procedure, and we can say the same. Now it's collecting the stats for the memory consumed for the each line of the code, and I'm using an extra small warehouse, and then we can call this system function. Let's copy this code, the report, and go back to the VS Code. I'm going to paste it here. Okay, you can see clearly, the two pandas almost close to 1.9 GB of data is being used as part of this warehouse, which is definitely, it's a lot of memory, and it's time consuming, as we called out. It's close to almost 97% of the time is taken for that part of the code, which is almost 14 seconds, I would say. Now let's go back and see how we can optimally do without the two pandas. For that, we can use I have the code here. This is leveraging the Snowpark data frame to do the same operation. Let's come on this part of the code, and let me use this and rebuild this procedure, and make sure we go back and set up the same parameter to line and invoke the sort procedure. Now it should bring down the time considerably less, because we're not exporting the data between data frames. And let's try to run the system function and pull in the report, copy, and go back to VS Code. Now this is from Snowpark, so differentiate Snowpark doing the data frame transformations, and now you can see the total time here is close to 1 second, and the millisecond you can see even less than a second. Likewise, we can also do the same for the memory, and call this store procedure, and the report, copy, go back here, same thing. Yeah, you will see a lot less. This is the memory used by the store procedure for 292 MB, and you don't see any increase in the memory compared to 1900 and whatever MB of lines, memory. So that's all I have. So you can clearly call out leveraging this profiler to understand which line of your code is the culprit, so that you can go and fine tune that part of the code, which helps you to optimize your procedures. Thank you.